It would detonate and demolish all of New York City, parts of Connecticut, and New Jersey. This is perhaps one of the best-kept secrets in our material science. Betelgeuse, a radiant miracle gracing the night sky, is a famous red, gigantic star. It has settled in the Orion constellation, astounding stargazers for quite a while. Recent concerns from renowned physicist Michio Kaku have suggested that Betelgeuse might have at long last detonated. How this event reshapes our understanding of stellar life cycles and the forces shaping our universe is an imperative inquiry. What thoughts does it hold for us? Stay tuned to find out. Imagine looking at the night sky and seeing a stunning star in the Orion group of stars. Betelgeuse, also called Alpha Orionis, is a huge, brilliant body at around 5 hours 30 minutes right ascension and 0 declination. Its name originates from the Arabic word Yad al-Jaws, meaning the giant shoulder. In 1603, astronomer Johann Bayer gave the star its exceptional name, Alpha Orionis, highlighting its status as the most conspicuous star in the Orion constellation. Despite its prominence, Betelgeuse holds its name proudly as a massive star with a mass several times larger than our Sun, making it a true giant. To put this in context, if the Sun were the size of a small marble, Betelgeuse would be a massive ball. Estimating its distance has been challenging, with measurements placing it somewhere between 500 and 600 light-years from the Sun, a massive distance in cosmological terms. In terms of brilliance, Betelgeuse shines brightly with an apparent magnitude of around 0.6. Harvard professor Morgan McLeod noted that Betelgeuse's size and proximity make it one of the few stars that astronomers can closely study using telescopes on Earth and in space. Telescope images reveal Betelgeuse's extraordinary features, showing a surface distinct from the Sun's smooth appearance. Instead of a uniform sphere of incredibly hot plasma, Betelgeuse appears as a pattern of uneven, frothy gas pockets, some as large as smaller stars. Enormous emissions of hot material rise from Betelgeuse's outer layers, resembling cosmic spring cleaning. One such event was so massive that traveling at the speed of light would take 75 years to cross it. This phenomenon, known as surface mass ejection, expels material from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. These ejections are not constant, but vary in relation to Betelgeuse's internal cycles. At just 10 million years old, Betelgeuse is astoundingly young compared to our Sun. Despite its youth, it has already burned through much of its hydrogen fuel, entering the later stages of its life as it transitions into the red giant phase. During this stage, Betelgeuse fuses helium to form carbon through nuclear fusion processes, driving rapid, notable changes fueled by its enormous initial mass. Scientists suggest that Betelgeuse began its journey as a blue-white star belonging to the largest group of hydrogen-burning main-sequence stars. Larger stars like Betelgeuse shine brighter and burn hotter, but this also leads to faster hydrogen depletion and an earlier transition to the red giant phase. Betelgeuse's surface temperature reaches stunning levels of up to 8,950 degrees Fahrenheit, a sharp contrast to the Sun's cooler 10,000 degrees Fahrenheit. As Betelgeuse depletes its hydrogen and begins fusing helium, its outer layers have expanded dramatically, making it one of the largest stars known. With a diameter greater than 700 million miles, Betelgeuse is incomprehensibly vast. Its surface temperature, now near 5,800 degrees Fahrenheit, is cooler than the Sun, yet it is 7,500 to 12,000 times more luminous. In 1836, astronomer John Herschel observed changes in Betelgeuse's brightness, classifying it as a semi-regular variable star with periodic fluctuations. These changes, mostly following a 400-day cycle, gained attention in 2019 when Betelgeuse displayed an anomaly, dimming by about 60%, a deviation from its normal pattern. This dimming was attributed to a massive material release that formed a dust cloud, temporarily obscuring the star. Although the dust cloud eventually dissipated, Betelgeuse has not fully returned to its prior state. Its 400-day brightness cycle has shortened to 200 days, sparking discussions about a potential imminent supernova. In a supernova, the star consumes its remaining fuel, causing the core to collapse and forming a black hole while ejecting outer layers at speeds up to 25,000 kilometers per second. If Betelgeuse were to go supernova, it would be a spectacular event, visible for months, comparable to the full moon. At a distance of just 650 light-years, it would be one of the brightest supernovae ever observed. While supernovae are common, they are usually too far away to be seen without powerful telescopes. Betelgeuse's potential supernova would be a significant event for astronomers and skywatchers alike. As stars age, their cores accumulate iron, eventually triggering a supernova. The last supernova visible to the naked eye, SN 1987A, occurred in 1987, around 168,000 light-years away. While this event provided invaluable insights into stellar evolution, its distance from Earth meant it had no significant impact on our planet. Betelgeuse, now the focal point of attention, is expected to go supernova. Astronomer Miguel Montargis predicts that its brightness will rise to that of the full moon when the supernova occurs. Imagine a captivating 2-month period where, on a clear night in a dark city, you could read a book illuminated by Betelgeuse's supernova. In 2021, Betelgeuse experienced another dimming event similar to the 2019 anomaly, with a 60% decline in brightness due to a cloud within the star's wind. This obscured part of the star, leading to a missing southern hemisphere in images. After this dimming, Betelgeuse suddenly brightened, though the cause remains unclear, fueling further speculation among astronomers. Betelgeuse, now 15 to 20 times the size of the Sun, falls into the category of stars expected to go supernova. Most astronomers suggest that Betelgeuse could explode within the next 100,000 years. However, a recent study by Hayuki Seo and colleagues from Tohoku University indicates that the star might be closer to exploding than previously thought. There are varying opinions on when exactly Betelgeuse might reach its final, explosive stage. Some researchers argue that the star's behavior could indicate a supernova is imminent within the next few decades, while others suggest it may remain relatively stable for thousands of years. Regardless of the timeline, Betelgeuse offers a unique opportunity to study the life cycle of massive stars and the processes leading up to their dramatic deaths. When Betelgeuse eventually goes supernova, it will provide an unprecedented view of this cosmic phenomenon. Such an event would allow astronomers to collect data on everything from the shock wave produced by the explosion to the heavy elements ejected into space. These elements, essential for the formation of planets and life, are the building blocks of the universe, recycled through successive generations of stars. Moreover, the energy released by Betelgeuse's supernova would likely have effects extending beyond astronomy. While the star is far enough away to pose no immediate threat to Earth, its explosion would flood the solar system with a surge of neutrinos and other high-energy particles, giving scientists the chance to study these elusive particles in detail. Neutrino detectors around the world, such as the Super Kamiokande in Japan, would be on high alert, ready to capture the fleeting signals from the star's core collapse. Betelgeuse's unpredictable behavior has already advanced our understanding of massive stars. Its dimming events, for instance, have shown how surface phenomena like convective flows and dust clouds can affect a star's observable properties. These insights could be applied to other red supergiants, helping astronomers refine models of stellar evolution and improve predictions about their lifespans. The fascination with Betelgeuse extends beyond science. Its prominent position in the Orion constellation and its vivid red color have made it a cultural and historical touchstone for civilizations throughout history. From ancient Middle Eastern astronomers to modern stargazers, Betelgeuse has inspired myths, poetry, and scientific inquiry. As we continue to monitor Betelgeuse, the anticipation surrounding its eventual fate reminds us of the dynamic and interconnected nature of the cosmos. The life and death of stars like Betelgeuse not only shape the galaxies they inhabit, but also influence the very fabric of life itself, seeding the universe with the elements necessary for creation. For now, Betelgeuse remains an enigmatic beacon in the night sky, its fiery heart still burning brightly, reminding us of the vast, ever-changing universe we are privileged to explore. This end, CIO's group bases their theory on creepy crawly juices. Conduct reliably growing and contracting within frequent pieces of information. While they don't predict an inevitable blast, they propose it could occur inside the following 1,000 years. Testing past time gauges, the vulnerability surrounding Betelgeuse's course of events has gotten the interest of stargazers. Anyway, some researchers contend that stars like Betelgeuse can keep going for more than 10 million years, a surprisingly brief period for cosmologists, yet still broad in the infinite scale. As they look for pieces of information about whether the brilliant star would be able to turn into a cosmic explosion, space experts have noted changes in its variety. Some describe the star's shade as like Saturn's yellowish color, instead of Mars' ruddy variety. This raises the question, has the star's tone changed? If this is true, it could indicate fast improvement, suggesting a cosmic explosion could happen sooner than expected. This variety shift offers a hint to the star's changes, helping specialists decipher infinite events. Whether Betelgeuse undergoes a cosmic explosion on time or takes as much time as needed to give a magnificent show, mankind will have a front-row seat to observe the perfection of one of the most uncommon, enormous peculiarities. What might occur if Betelgeuse went supernova? The plausibility of a cosmic explosion showing up in our sky has caught people's minds. New reenactments are helping space experts understand what we could witness when Betelgeuse ultimately detonates, expected inside the following 100,000 years. Anyway, uncertainty remains. Insect juice is around 500 light-years away, and later research suggests that for a cosmic explosion to recognizably affect Earth, the star should be within around 150 light-years. Around quite a while back, an event of this nature might have played a role in a mass extinction, influencing marine life. After the Perian demolition, if a cosmic explosion were to occur within 30 light-years of Earth, things could get precarious. However, Betelgeuse's cosmic explosion isn't expected to undermine life on Earth. There might still be some environmental impacts. The blast would deliver a surge of ultraviolet radiation, possibly causing a brief diminishing in the ozone layer. Anyway, research shows that any subsequent ozone exhaustion would likely be minor and fleeting, with limited environmental repercussions. Right away after the blast, we would recognize weightless particles called neutrinos, which are innocuous to us. The star would quickly become brighter, reaching a glow like the full moon in practically no time. Betelgeuse's splendor would then wane, gracing our skies for around half a year to a year. As sun sets, it would remain an apparent showcase for another 1 to 2 years prior to blurring. Eventually, Orion would lose its red sparkle, a sparkle for eternity, scratched in memory. In the aftermath of a cosmic explosion, the blast would create grandiose beams and high-energy particles that can infiltrate Earth's magnetic shield. Anyway, aside from the near supernova, these sums would be somewhat minor compared to different types of radiation we experience. The cosmic explosion's last stunning showcase wouldn't simply entrance us. It would also create radioactive iron, a critical mark found in Earth's sea depths and, surprisingly, on the Moon. This iron, born from a cosmic explosion that happened 2 to 3 million years ago, was something like 300 light-years from us. Luckily, its closeness represented no huge danger to life on Earth. Rest assured, such a nearby cosmic explosion is an incredibly rare event, possibly happening just once in a billion years. As theory swirls around the expected appearance of a Betelgeuse cosmic explosion, space expert Andy Howell from the University of California isn't happy with simple back-of-the-envelope computations. Seeking accuracy, he enlisted the help of 2 former graduate students, Jared Goldberg and Evan Woods. Their intricate simulations portray the star's epic finale, integrating uncertainties while drawing insights from observations of the 1987 cosmic explosion SN 1987A, the nearest recorded cosmic explosion in current history. These stargazers concluded that life on Earth would remain safe. However, the enormous event would undoubtedly not go unnoticed. According to Goldberg and Wood's findings, when Betelgeuse ignites, its brightness will look like the delicate glow of a half-moon, shining about 100 times fainter than the full moon. This hypnotizing brilliance is expected to beauty our skies for more than 90 days. Later studies show that insect juice is near 724 light-years away, securely outside the normal risk zone. Anyway, the cosmic explosion could have captivating ramifications for Earth. Howell notes that many creatures depend on the moon for navigation and may be confused by a brilliant object. Stargazers themselves would face challenges, as the extreme brilliance would surpass the capabilities of telescopes and space observatories. To compensate, telescopes would need to capture the subtler, gentler glow of the star. Specialists promise the public that we will have sufficient warning if Betelgeuse goes supernova during our lifetimes. Earth's instruments would detect signals like neutrinos or gravitational waves produced by the blast, giving us a heads-up as much as a day prior to the event. Although this event isn't expected to occur for another 100,000 years, insect juice will eventually go cosmic explosion, and the result will rely upon the materials left behind after the fabulous finale. As researchers continue to refine their expectations and expand their understanding of such enormous phenomena, observations of similar stars at various stages of their development provide fundamental information for modeling the life cycles and potential hazardous ends of massive stars. This data helps astronomers evaluate the frequency and effect of supernovae in our galaxy, contributing to our broader understanding of vast events and their implications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also helps refine the cosmic distance scale. Accurate measurements of such stars' luminosity and behavior improve our methods for determining distances to far-off worlds, enhancing our general mapping of the universe. Moreover, supernovae serve as essential tests for understanding the synthesis and distribution of heavy elements like iron and nickel throughout the universe, elements crucial for the development of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, utilizing cutting-edge technology to detect any signs of approaching change. These efforts ensure that we are ready to observe and study one of the most dramatic events in the universe's life cycle, enhancing our understanding of the dynamic processes that shape the cosmos. As researchers continue to study the evolution of massive stars, the potential for discovering new phenomena increases. By observing stars like Betelgeuse, scientists are able to further test their theories about star behavior, supernova mechanics, and the distribution of elements in the universe. Each new observation adds another piece to the puzzle of how these colossal stars interact with their surroundings and how their explosive deaths can influence the formation of new stars, planets, and possibly even life. The study of these supergiants provides insight into the future of our own sun, even though it will end its life in a vastly different way than stars like Betelgeuse. While our sun will eventually become a red giant before shedding its outer layers and leaving behind a white dwarf, supergiant stars like Betelgeuse undergo a much more dramatic and violent death, culminating in a supernova explosion. Understanding the life cycle of these stars allows astronomers to predict the eventual fates of other distant stars and gain a better understanding of how galaxies evolve over time. In addition, the study of supernovae and their aftermath has far-reaching implications for fields beyond astronomy. The creation of heavy elements during a supernova is crucial for the formation of planets and, ultimately, life. Elements such as gold, uranium, and platinum, which are vital to the construction of planets and the development of life as we know it, are forged in the heart of supernovae. Without these events, the universe would be a much less interesting place with fewer materials to build stars, planets, and even life. Looking forward, astronomers will continue to closely monitor stars like Betelgeuse, using the latest advancements in technology to track any signs of impending changes. When the moment arrives, whether in 100,000 years or longer, it will be one of the most exciting astronomical events in history, providing a unique opportunity to study the violent end of a massive star and its impact on the surrounding space. The lessons learned from Betelgeuse and other supergiants will not only deepen our understanding of the cosmos, but also help us prepare for the unknown futures of the stars around us.